The students see this question number 16 from chapter 15 of HC Verma. The chapter is waves. A string of linear mass density 0.5 and a total length 30 centimeter is tied to a fixed wall at one end and to a frictionless ring at the other end. So this is your string. Okay, here the string is fixed to a wall and here it is tied on a ring. This ring can slide vertically freely on this rod. So a wave pulse is produced on the string which moves towards the ring at a speed of 20 centimeter per second. This is your wave pulse. The pulse is symmetric about its maximum, which is located at distance of 20 centimeter from the end joined to the ring. So this is your pulse and this distance is 20. Assuming that the wave is reflected from the ends without loss of energy, find the time taken by the string to regain its shape. So see, this pulse is traveling towards the free end. It is going like this, going like this, going like this. When it reaches the free end, it will be reflected back again in the same shape and it will come back like this. Okay, because this is a free end. Okay, so when reflection happens from a free end, the phase does not change. If the pulse is going upward like this, it will come back in the same manner. Okay, so same thing is happening here. This is your pulse going. It will travel a distance of 20 centimeter to reach the end of the string, and again it will come back in the same direction. It will be still positive pulse, it will not be a negative pulse. Okay, so it is coming back again. It has to travel a distance of 20 centimeter, so it has to go by 20 centimeter and come back by 20 centimeter. Then the string will be again in its original shape. So the total distance traveled is 40. So time taken will be how much? 40 centimeter by speed of the wave 20. So this will be equal to 2 seconds. So that is the answer to the first part. Now they are asking that the shape of the string changes periodically with time. Find this time period. Okay, observe. See, suppose this is your pulse and it is initially at the left end. Right. The total length of the string is how much? Total length of the string is 30 centimeter. So this pulse is traveling a distance of 30 centimeter, reaching this end. When it is reflected back, it will come back again as a positive pulse. So it will come back and reach this point. Now this pulse has reached this point, and when it is reflected from the fixed end, what will happen? The reflected pulse will be inverted and will be now going like this. So again this pulse is now going towards right, traveling a distance of 30 centimeter, and when it is reflected from the free end, it will be still a negative pulse. It will come back. I should remove this arrow. It will come back and travel again a distance of 30 centimeter. Okay, now from here, when it is reflected again from the fixed end, the pulse has now gained its original shape, and again the story will repeat. So first a positive pulse is going in this direction and coming back, then a negative pulse is going in this direction coming back. So what is the total distance traveled? 30 plus 30 for positive, again 30 plus 30 for negative, and then the story repeats. So total distance traveled is 120 centimeter. And what is the speed of the pulse? Speed of the pulse is 20 centimeter per second. Okay, so time taken will be how much? 6 seconds. And this is the actual this is the answer which is actually wrong in the book, what I feel. Okay, in the book the answer is given to be 3 seconds, but what I feel is that the answer should be 6 seconds, because the story of the pulse repeats after every 6 seconds and not 3 seconds. Okay, so anyways, so the time period of the pulse should be 6 seconds according to me. Now they're asking what is the tension in the string. So that is very easy. Linear mass density is given. So wave speed is given by root of t divided by mu. That means tension T will be equal to mu v square. So mu is how much? 0.5 gram per centimeter. Okay, 0.5 gram per centimeter times v square is what? Velocity is 20 centimeter per second. So 20 times 20. So this will be equal to 200 dynes. Okay, this is the CGS unit of the force.